Alright friends, welcome back. In this video we're going to go ahead and cover the last conic section that we are going to discuss here in section 4.3 of your textbook, and we're going to start off with the exact same setup. We're going to have this double napped cone, and then we're going to chop up the cone in a certain way and get a brand new shape. So if I go ahead and demonstrate that to you here, right, we've already talked about circles, we have talked about ellipses by just tilting that a little bit. If we continue to tilt this more, then that is going to be the shape of a parabola that we've already talked about. If we go ahead and tilt this all the way so that our plane is vertical, then what we get is this this shape that looks like it is basically two disjoint pieces, right? So we have this piece that is up top, and then we basically have its mirror image down there on bottom. And this is a new shape for us that we get by cutting a cone in this way, and this is going to be something that we call a hyperbola, okay? And so this is kind of the most odd shape here because it definitely looks like the entire shape is just, again, these two disjoint pieces that don't touch each other. But this is actually a very, very famous type of conic section, and we're going to go ahead and talk about how we go ahead and graph that in this video, okay? So taking a look here, there are a lot of different vocab terms when it comes to hyperbolas, and I know that you're probably staring at the screen right now and starting to sweat because of how complicated everything looks, but I promise you that it's really not too bad. I'll let you go ahead and read through those definitions here, but basically what I want to do is go ahead and introduce all of these terms by introducing this next little interactive, okay? So just kind of defining what a hyperbola is geometrically, we're going to do this the exact same way that we've done the other ones. Basically, you might have noticed a trend by now that all of the conic sections can be defined by just saying it's the collection of all points that are something to do with distance, okay? So for a circle, it's the collection of all the points that are the same distance away from the center. For a parabola, it was the collection of all points that are the same distance away from the focus as it is from the directrix. And then for an ellipse, it was the collection of all points that have a constant distance away from the two foci, okay? And so here a hyperbola, we just want to kind of get a sense of what is this definition going to be, right? It's the collection of all points that are what in terms of distance, okay? Well, in this interactive, you got a couple of things that you could play around with, and this is in today's Schoology folder for you. So first of all, you see this point right here. It says P with the coordinates X, Y. What you're able to do is take your mouse and go ahead and drag this anywhere you want on this branch of this hyperbola, okay? You can't take this point and put it over on this branch, but the argument would be the same as if that point were on that branch that was on the left there. And then you'll notice that we keep track of a couple of things here, right? So F1 and F2, these are the foci. So these are the two focus points that we are going to be looking at, just like for an ellipse. This is where we would put our thumbtacks to make the shape. And then you'll notice that we basically have the shapes here, and then we have this little bit in the middle. This is a line segment that is going to connect the two vertices of our hyperbola. And that's a new vocab word for you guys. We're going to call that a transverse axis. And we're going to need to point that out because this is how we define a hyperbola. We go ahead and point out this distance here in green away from the first focus with our point, and then this second distance here in red, that's the distance between our point and the second focus. And so again, you can take this point and you can move this anywhere you want, and you'll notice that that red and green distance will always be something that we are going to be keeping track of. The way we get a hyperbola's shape is by understanding the relationship between these two distances away from the foci and the length of this transverse axis. And so to demonstrate that relationship, we're going to take this slider down here that says slide me, and we're going to kind of understand how those three lengths are related, the blue, the red, and the green. So you notice as I begin to slide that slider, what they're doing is they're just kind of showing you the length of that transverse axis. Again, that's the length in between the two vertices. They're just taking that and copying that and moving it straight up. And then once they have that copied up there, what they're going to do is they're going to take these two distances away from the two foci, and they're going to show you how they're related to that transverse axis. So once we get that up there, we're going to take our green distance. Remember, that is the distance from the point that we selected all the way to the first focus. They're just going to go ahead and move that and lay that right on top of our copy up here. And then as we further slide, we're going to take this red distance right here, and we're going to put it right on top of that green distance. And if you continue with the slider, what we're basically trying to demonstrate to you here is that you definitely get that length of that transverse axis by taking that green length and basically chopping it off right here between these two dotted lines, right? So we're basically taking that green length, that was the length from our point all the way to the first focus. We're basically taking a scissors and chopping it right there. That's the length of our transverse axis. Well, how much of the green distance do we take away? Well, that would be the length of the red distance here. So what we're saying is that you get a hyperbola by taking the length that you get from your point to the first focus. You're going to subtract away the length from your point to the second focus, and then you get exactly that length of that transverse axis in all cases. If I go ahead and reset everything here and maybe move my point to a different place, we'll go ahead and demonstrate this here one more time. We're going to take that transverse axis here. We're going to take a copy of that green distance, a copy of that red distance, and you can see that that works out perfectly, okay? And so that is what makes the shape of a hyperbola the distinct shape that it is. It's the collection of all points that the difference of their lengths from the focus is always going to be constant, and that constant length is going to be the length of that transverse axis, okay? So just a bunch of different vocab terms and things that I want you to be familiar with. Let's get into the meat of what we're going to be talking about here. And of course, that's going to be the standard equations for a hyperbola. So just as we saw for parabolas and for ellipses, we're going to have two different cases for a hyperbola. And so in that first case here, this is going to be the case where we have x coming first, because keep in mind, we are talking about a hyperbola as the difference between distances here. And so what makes these different from ellipses is the fact that instead of a plus in the middle, you're going to have a minus in the middle. And the way that you distinguish between the two cases is you remember that subtraction does have an order, right? You just have to look at what variable is coming first. What minus what, right? So here in case 1, I'm taking my x and then I'm subtracting away my y in that order. In case 2, you'll notice that I'm taking my y and subtracting away my x. So in both of these cases, we're going to have to kind of keep that in mind, okay? And then, of course, to distinguish between the two cases here, we're going to go ahead and say here that since x comes first in case 1, this is going to be your horizontal case, where your hyperbola is going to be drawn a little bit more horizontally. And in case 2, this is where y comes first. That's your vertical case. This is where your hyperbola is going to be drawn a little bit more vertically. Okay, so that's how you tell between the two. And then, as always, you have all these different characteristics that all have formulas that tell you what each of these moving pieces are. And instead of kind of reading through them, I'm just going to go ahead and demonstrate them in an example here in a moment. One quick thing that I do want to point out is in your notes, what I have printed on the page is the formula that you can use to get your asymptotes for a hyperbola if the center is at 0, 0. But what I want you to do is also go ahead and write down this other formula here in your notes. And this is the more generic formula when your center is at a point with coordinates hk, okay? That is not something that I printed on the notes, and that's actually not something that I printed on your Conic's reference sheet. So that is something that you'll want to go ahead and write down somewhere, okay? Same thing over here in case 2. You'll notice that basically the only difference is that slope in front. Instead of b over a, it is now a over b, but same thing applies. This is where we have a center of h and k, and this is how we get our asymptotes, okay? And so that is one thing I guess we haven't pointed out yet, is that hyperbolas do in fact have asymptotes. So you have the two distinct shapes. Your asymptotes are going to be more diagonal lines that go through the plane in this way. So when you draw a hyperbola, part of the problem is that you're going to have to go through and point out where the center is, and then point out a couple of additional things that are going to allow you to place those asymptotes correctly. And it's really going to be those asymptotes that are the guidelines for drawing the rest of the shape here, okay? And so I want to go ahead and demonstrate that. You notice that I've already done some work here just to kind of save some time in the video. And the reason that I've already kind of gone through and done all of the work here on part A is because the example that you were given actually looks an awful lot like the standard equation for a hyperbola already. We just have to do a couple of additional little pieces of work here in order to go ahead and look at it as that actual form, okay? So namely here, if you take a look at what I've highlighted in blue and green, there's my X team, there's my Y team. Basically, I just went ahead and rewrote what was already there, okay? I have a 1/4 in front of my X team. I just went ahead and rewrote that as a big divided by 4. I have basically what is a 1 in front of your Y team. I went ahead and just wrote that as a divided by 1. And again, that's just for the interest of being able to write these in a little bit more of the standard form. It's from here that you can go ahead and point out your values of H and K, and then A and B according to your formulas up above. And what you'll notice here is that this is, of course, going to be a case 1 hyperbola. The reason that we know that is because this is going to be subtraction, and the order does go x minus y. And so that tells us that this is going to be a case 1, or in other words, the shape of this hyperbola is going to be more horizontal, okay? And then just following the formulas from up above, we're able to go ahead and get all these different characteristics like the center, the coordinates for our vertices. You have something called the transverse axis and then the conjugate axis. I'll demonstrate those here in a little bit. And then we, of course, use those formulas up above, the one that I asked you guys to go ahead and write down up here. We're going to use that formula to go ahead and write down the equations of the asymptotes that we're going to get. Okay, so while I'm asking you to point out all these different characteristics, it's going to be taking this over to the grid where we're going to be doing the majority of our work. And let's go ahead and get started with that here. So the very first thing that we're going to do is the same thing that we've done for all the different conic sections. We're going to go ahead and find the exact center of our grid and then plot that point. So I'm going to go ahead and just kind of eyeball that here. There is where the center of my grid is. Again, I've given you a 16 by 16 grid, so if you want to count 8 in and then 8 from the top or the bottom, you can find the center that way. But we plot our center point here, okay? It's at this point that we want to go ahead and plot our two axes. Okay, so we have our transverse axis and then our conjugate axis. And you can go ahead and read through the definitions that are earlier in your notes, but basically what we need to take a look at here are going to be these values of A and B. Okay, we know because this is a case 1 hyperbola that this is going to have a shape that is going to be more horizontal here for us. Okay, and so what that's going to mean here is that we are going to have a shape that is going to be more emphasis in the x direction than it is going to have in the y direction. And so that is how I know to start at my center here. And then because playing the role of A is 2, I'm going to count 2 to the right and then 2 to the left to plot those points. Okay, and then of course here what I will do next is I will go ahead and look at my number B, and that is how far I go north and south. Okay, so I'm going to start at my center and go up a length of B north and go down a length of B south. Okay, this is, as a matter of fact, the exact same steps that you would take to graph an ellipse. Okay, but now that you have these points on here, this is where things are going to get a little bit different, because what we're going to be basically drawing here is a box. Okay, so we're not going to draw an ellipse around these points. What I'd like us to do is go through and draw a little bit of a dashed box around these. And I know that this kind of seems a little bit awkward, but if you draw that box, you're going to have an easier time drawing the rest of this shape, because the only thing left to do here is to take a straight edge. Now that you've got that box in there, what I'm going to do is I'm going to line up my straight edge here to opposite corners of my box, and I'm going to go ahead and draw my asymptotes. This is actually a really easy way to go ahead and plot those asymptotes without even having to worry about the equations that you calculated earlier. So I'm going to go ahead and connect those two opposite corners and make an asymptote, and I'm going to do the exact same thing with these two opposite corners. So once you get the center plotted, and you use A and B to get those other points plotted, those points are called the vertices and the co-vertices, then we could draw that box around them and then just connect opposite corners to get this this little net for what we're going to be drawing in the rest of the shape here, okay? And so now that we have that frame or that net drawn, it's now time to go ahead and pick up with what the rest of the shape is going to look like here. We know that this is going to be a horizontal shape, and now that we have that net down, it's actually super easy to get the rest, because we have these asymptotes. We know that they're going to have to pass through these two vertices here, and so what I'm going to do is I'm just going to go ahead and sketch the rest. So I'm going to get really close to my asymptote with my end behavior up here, coming down to the vertex, and then swooping through, and then mirroring that same shape on the other asymptote, just like that. Okay, pretty easy. We'll have to do the next part here, so let's go ahead and do that same thing. We're just going to go ahead and follow the asymptote till we get to the vertex, and then from the vertex, just keep following that exact same shape until we get the rest, just like that. And if you're in OneNote or PowerPoint Online, make sure that your ink to shape is turned off, because this is really going to play havoc with that if you don't have that, okay? And so there would be a basic shape of the hyperbola, but now we need to, of course, go through and do something that we've done for all the other conic shapes, which is to place our asymptotes correctly. And this is where we always went back to wherever the center of your hyperbola or the center of your conic in general was, and then we went and worked backwards to get those axes placed here, right? So that center needs to be at a point with coordinates 1, -2. That means from the origin to the center, I need to go 1 to the right and then 2 down. So I'm going to work in the opposite direction from those two, okay? So because I need to go 1 to the right, I'm going to start at my center with my vertical ruler here and go 1 to the left, okay? Again, it should look like once you place these axes that your center has been plotted correctly, okay? So working backwards does the best job at making sure that we are able to do that, okay? And then because the y-coordinate of my center is a -2, that means I have to go down 2. So I'm going to work backwards from that and go up 2. And that is where I would place my x-axis right there, Okay, and obviously where they intersect, that would be the origin point. So you can now just go through and check that your center was plotted correctly by starting at the origin and going 1 to the right and then going 2 down, and that's exactly where we would have our center. Okay, so just kind of going through and checking that, and that would be a complete problem. Okay, so just kind of going through, making sure that you're in standard form, drawing your hyperbola correctly. What I've done here already is I've gone ahead and reached for Desmos.com to go ahead and give us a little bit of a more computer-generated picture of this graph, and you can see here that it's very similar. The reason why it might look just a tad bit different is because I'm starting with a 16 by 16 grid here, and Desmos is working with a 20 by 22 grid here. So they're going to look a little bit different. The zooming is different in both of these graphs, but you can see that the same general idea is there. So you could always use a graphing utility to go ahead and make sure that your graphing is correctly, and I think Desmos is the best one. Going through here, you'll notice that B is completely blank. We're going to go ahead and do this one together. And what we're going to do here is we notice that we are given this general equation right here. We need to go ahead and rewrite this in standard form. So if you've been keeping up with the previous couple of Conics videos, this is going to be the exact same strategy that we're going to use for this. So we're just going to go ahead and do this quickly, right? So I'm going to go ahead and get all my X team members together and get all my Y team members together. So we'll do my X's in blue, and then we'll go ahead and do my Y's here in green. Okay, and so just kind of grouping everything together, we have a negative x squared plus 2x. I'm going to skip a little bit of space and say plus. And then for my y team, I've got 9y squared plus 54y. And then it looks like that 44 is not a part of either team, so of course we're going to go ahead and move the 44 over to the other side where it will become negative 44 because we're simply just subtracting it. Okay, and now here's where we need to go to both groups and make sure that we have the green light to complete the square. Remember that you need the number positive 1 in front of your squared term before you start completing the square. And it looks like in both teams, I'm going to need to factor something out first. In the blue team, I'm going to need to factor out a copy of negative 1. That's going to leave behind x squared minus 2x. And then in my y team here, I'm going to have to factor out a 9. Okay, so if you factor a 9 out of everything, that's going to leave behind y squared plus 6y. And then we'll go ahead and say that that is all equal to the negative 44 on the other side. Okay, and now it's here where we can go ahead and perform that completing the square step. And so we're going to take our b number divided by 2 and square the result. In my x team, I'm going to get plus 1. And in my y team, I'm going to get plus 9. Okay, and so we're just going to have to be a little bit careful about what we really introduce to that side, so we make sure to introduce the proper thing to the right-hand side. Keep in mind, we did introduce a plus 1 to the x group, but it was in this group where everything was being multiplied times a negative 1. And so what that means for us is that I'm not going to write plus 1 on the right-hand side. I'm going to write minus 1, because that's what we get when we ever retake a negative 1 times 1. Okay. For my y group, I did say plus 9 inside here, but that was a family where everybody was being multiplied times 9. And so 9 times 9, of course, is going to be 81, so that means I'm going to add that over to that side. Okay. I've been helping some folks out in the past couple of days, and this is definitely where people are having the most shortcomings in this work, so just make sure that that's a step that you can make sense out of before you continue. Okay. And so now we can go ahead and simplify that right-hand side. We simply just have negative 44 minus 1 plus 81. So if you go ahead and just reach for a calculator for that, or maybe you're able to do that mentally, you're going to find that that's going to turn out to be 36. Okay, and to get our x and y teams simplified down here, again, we've completed the square, so we can now write them as a perfect square. For my x team, I still have that negative in front. I'm going to go ahead and write my binomial squared, and then plus. For the y team, I have that 9 out in front, and then my binomial squared. So for my y team, that of course is going to look like y plus 3, and for my x team, that's going to of course look like x minus 1. Okay? And so now we're close, but remember, if you check back up here on the standard equation for a hyperbola, what we specifically need is going to be a 1 on the right-hand side in both cases, okay? And so if you don't have that at this point, we need to go ahead and perform that same step that we saw with ellipses, where we need to go through and divide everything by a copy of 36. So we're just going to go ahead and do that to everything in the equation and then simplify accordingly. Okay, so on the right-hand side, 36 over 36, of course, makes 1. That was the whole point of doing that. And then on the left-hand side, we're just going to need to go ahead and simplify what we've got as much as possible. Okay, and the way that we do that, remember, of course, is we take a look at that number in front of my binomial and we divide it by what we are having here in the bottom, and we need to reduce that fraction here. So in the x team, it looks like I have negative 1 over 36. That doesn't really simplify too much for us here, so I'll just write that as a negative fraction, x minus 1 squared all over 36. and then I'll say plus here for my x team, 9 over 36, that is a fraction that reduces to 1/4. And so I'm going to go ahead and write my y team as y plus 3 squared all divided by 4, okay? And just make that look a little bit nicer, we're going to say that that equals 1, all right? So we have something that looks an awful lot like what we want in our cases here, but you'll notice here what I'm left over with. I'm left over with an extra negative in front of my x team, okay? Anytime you ever take a negative number, for example, like -2 plus 3, we can always flip that around and call that 3 minus 2 and get the same result here, okay? There's nothing special about 2 and 3. That was just so I could explain what we're about to do a little bit more clearly. We're going to trade my y and my x teams around so that the order is what we need it to be, okay? So we're going to go ahead and put my y team in front. So y plus 3 squared all divided by 4. And then we're going to say minus my x team, okay? And that's going to be x minus 1 squared over 36. And that is equal to 1, okay? So we definitely now have it. This is going to be the standard form for our hyperbola, and it's going to be using this form that we can now go ahead and identify which case we have and how we're going to go ahead and continue here. So I've already got some spaces down here for me to be able to write that, okay? Now, because, again, we are subtracting, that means it's a hyperbola, and the order goes y minus x. And so that is going to be a case 2 hyperbola, or in other words, this is going to be more of a vertical looking hyperbola for our needs here, okay? Going through and pointing out those values of a and b and h and k, we could see here that playing the role of h is going to be a positive 1. And again, check the case 2 formulas from up above to make sure that you're matching up to the correct one. For k here, that is going to be played by -3. Playing the role of a here, remember that that is going to be whatever number you square to get these numbers on the bottom here. So playing the role of a, since 4 is just simply 2 squared, that is simply going to be 2. And then 36, that is simply just going to be 6 squared. And so playing the role of b is going to be 6 here for us. Okay, and then just kind of going through and applying all the different formulas from up above in case 2. For the center, of course, that's going to be the point with coordinates hk. So we said that h was 1 and k was -3. So we're going to have a center at a point with coordinates 1, -3. For the vertices, I'm not going to demonstrate actually applying the formulas. We've done that with the past couple of conics. I'm just going to go ahead and write down the result that you get here. So for case 2, that's going to be the point with coordinates 1, and then we're going to need to add k and a together. So that will be -1. And then for the second vertex here, we're going to go ahead and say 1, and then we're going to subtract k and a. So that'll be 1, -5. Okay? Now, TA and CA, that's my transverse axis and my conjugate axis, okay? And so basically all we're doing here is we're calculating the lengths of those two. And again, that will translate to the picture here in just a moment, all right? And so for the transverse axis, that's just going to be 2 times A, so that'll be 2 times 2, which of course makes 4. And then for the conjugate axis, that's going to be 2 times 12, which of course, or not 12, goodness, that's going to be 2 times 6, which is going to make 12, I meant. There we go. All right, and then of course for the asymptotes, we have that formula from up above in our notes here, the one that said y is going to be equal to plus or minus, and then because we are in case 2, we want a over b. So playing the role of a is 2, playing the role of b is 6, and then we're just going to pick up with the rest of that formula that we wrote down before, right? So that would have been x minus h, which is being played by 1, and then we're going to add on k. So that'll be plus -3, or in other words, subtract 3 at the end. So we'll clean this up a little bit. We'll say here y is equal to plus or minus the fraction 2/6, that reduces to 1/3, times this quantity minus 3. And then as far as simplifying those asymptotes down, you could keep going with that, but this is a good way to represent that right here. So we have all the different characteristics that we wanted, and it's going to be, kind of using these characteristics that we're going to get that characteristic shape for our hyperbola. So let's go ahead and demonstrate that here again. Okay, so I've got my blank grid. Again, as always, I'm just going to go through, and I'm going to go ahead and find my center. Okay, so we're just going to go ahead and plot that right in the middle there. Okay, now because we have a case 2 parabola, this is going to be a vertical one. That means it's going to have more emphasis in the x direction, right? We're going to go ahead and plot those here. So on either side of my my center here, I'm going to go ahead and plot 6 to the east and then 6 to the west. Okay, after that, I'm going to go ahead and go up and down the length of A, so that's going up 2 and then down 2. And again, it's the exact same steps for an ellipse, so if you want to go back and watch that video as well, that's what we're doing here. And then what makes this different from an ellipse, of course, though, is that we are now going to go ahead and draw that box, okay? And this is where those key vocab terms of the transverse axis and the conjugate axis come through here, right? So remember that the transverse axis and the conjugate axis, these are basically the lines that we're drawing on our box, okay? And so we're just going to go ahead and get those drawn in here. I'm just freehanding that. And if you get that box drawn, again, you could take a straight edge here and you can go ahead and line it up to opposite corners and then get those diagonal asymptotes drawn in. Okay, so we'll just do that here really quick. So just kind of drawing those in. Again, you could go down to your equations and plot your axes and then use y equals mx plus b to plot your lines for these asymptotes if you want to do it that way. But drawing this box, I think, just makes it so much easier. And so that's what we'll go ahead and do here to draw these asymptotes here on this picture. So just kind of continuing to go through here, drawing these asymptotes. Because once you get this net or this frame drawn in here, then you're going to be able to get the rest of the hyperbola really easily. Because again, we said this is going to be a case 2 or a vertical hyperbola. So this one's actually going to be very wide here for us. But we're going to start up here at this vertex and down here at this vertex down here. And we're going to go ahead and just kind of follow the box and then follow our asymptote to get the general shape of what this is going to be. Okay, so again, this is going to be a very wide hyperbola here. But that is definitely the correct shape there, okay? And so now that we've drawn that, we just need to go ahead and get our axes drawn in there. So we're just going to go ahead and start here at the center with my vertical here. We know that the point at the center is going to have coordinates 1, -3, so that means 1 to the right and down 3 from the origin. So we're going to work backwards from that. I'm going to take my vertical here, and I'm going to go 1 to the left, working backwards. I'm going to place my y-axis there. And then from my center point, I'm going to take my straight edge horizontally. And then because I had to go down 3, I'm going to work backwards from that and go up 3. And that is where my x-axis will be. Okay? So there we go. Y-axis, x-axis, and 0. Okay? And so that is my hand-drawn picture. Here is a little bit more of a computer-generated image of that hyperbola. Again, this is from Desmos.com. You could feel free to go ahead and use that service as well, just to kind of check your results here. But I think that that's pretty good. All right, moving right along here, you'll notice that the third and final example that I've had here is basically already done for us just for the sake of time in the video. So if you want to go ahead and pause the screen and make sure to read through this one just to make sure that it makes sense to you, I think that would be a really good idea, okay? And then, of course, over here, this is the computer-generated image from Desmos.com. You can see our pictures are very similar. Again, the grids are a little bit off, so that's why they look a tad bit different, but the same general spirit has been preserved there. So, again, just kind of giving you guys some ways that you could be checking your work here. So, that's all I have for this video. Thank you very much for your attention. If you guys have any questions whatsoever, then please, as always, feel free to let me know. But I will speak to you guys in the next one.